Welcome to this session. We are looking at carbon, and in this presentation, we are basically focusing on the chemical properties of carbon. Okay. In our first session, we looked at carbon, and we realized that it's one of those abundant elements, and that it exhibits what we call allotrophy, where it exists in several forms, but does not change its state. Okay, so in the reactions that we are going to look at, we are going to see how carbon reacts with oxygen. We are going to look at how carbon reacts with the metal oxides, and then we shall look at the reactions of carbon with acids. Okay, sulfuric acid and then nitric acid. So those are the reactions that we are going to look at. So carbon generally is not very reactive, and that's why our presentation is actually going to be very short. It's not as reactive as compared to other metals or other non-metals or solids, for example. So the reactions are quite few. Okay, they are quite few, and these reactions occur in specific conditions. We shall see the reaction, for example, here, the reaction of carbon with oxygen. Okay, we'll realize that carbon reacts with oxygen in two ways, or carbon bonds in two ways. Okay, the first way is when we have plenty of oxygen. Okay, we often use the word excess. Okay, carbon burns in excess oxygen to produce carbon dioxide gas. Okay, so carbon, which is solid, reacts with oxygen, which is a gas, to produce carbon dioxide, which is a gas, and a lot of heat is actually given out. Okay, so that is the reaction of carbon, or that is how carbon burns. Carbon burns to produce carbon dioxide if the oxygen supply is plenty. When there is limited oxygen, that is to say that the oxygen is not much, then carbon burns to form carbon monoxide. Okay, so this reaction here, carbon with oxygen forming carbon monoxide in that equation. This is quite important. Why? Because when for example, you're cooking using charcoal here, what you see here, and you have closed the windows and there are no ventilators, carbon monoxide will accumulate in the room, and this will cause carbon monoxide poisoning, and this will kill you silently. Okay, so when you're cooking using charcoal, make sure that if you're cooking inside, make sure that there is sufficient supply of oxygen, such that you don't have carbon monoxide building up, causing carbon monoxide poisoning. So let's look at the second category of reactions, the reactions of carbon with oxides. Okay, with oxides. The oxides that we're talking about the oxides of metals. those that are in the lower end of the reactivity series. The reactivity series is basically a list of metals that are classified in accordance to the extent of their reactivity. Okay, so when we have carbon with these metals lower in the reactivity series, we are going to have reductions of these oxides. So we are going to look at the lead oxide, we look at copper oxide, we look at the zinc oxide, and then the iron oxide. We are going to see what basically happens. So remember that reduction, one of the definitions of reduction is removal of oxygen. So we are saying that carbon reduces these metal oxides, and then itself it gets oxidized to carbon dioxide. With the only exception of zinc. Okay, so lead oxide is reduced to lead plus carbon dioxide, and then copper oxide is reduced to copper, and then the carbon getting oxidized to carbon dioxide. And then the zinc, which is the exception here, instead of oxidation of carbon to carbon dioxide, there is oxidation of carbon to carbon monoxide. Okay, so often we can test you in whether you have understood these concepts using questions that reflect the color changes that can happen if carbon is heated together with these metal oxides. What will happen? So that's why we have the color changes that we have put here. Okay, so for lead oxide, it's yellow hot. When it is hot, it changes to reddish brown, but it is lead. Okay, and then copper oxide, which is black, after this reaction turns to reddish brown, and that reddish brown is basically the copper. And then with the zinc, you're going to have the white solid basically turning into yellow when hot. That is the reaction there. And then iron oxide turns from, still the reduction is the same, it's reduced to iron, and then carbon dioxide is also reduced. So it turns from red to silver beads, which basically are iron. Another reaction which is also important to note is the reaction of carbon with the steam. When we talk about steam, we are talking about the water in gaseous state. Okay, so this is basically a drastic reaction. You need to first heat the water so that you get the steam, and then the steam reacts with the carbon. The reaction is that you form carbon monoxide gas plus hydrogen. Okay, and then lastly, let us focus on the reaction of carbon with acids. Okay, and we are illustrating this using sulfuric acid and nitric acid. Both these should be concentrated, and that is why we earlier on said that the reactions of carbon happen in particular conditions. Okay, when conditions are set, carbon can react, but generally it is not very reactive. Remember that statement. So here, when we have concentrated sulfuric acid reacting with carbon, you will have water, carbon dioxide, and then sulfur dioxide. Okay, that's what will be formed. Okay, this is basically a redox reaction where you have oxidation and reduction happening at the same time. So carbon reacting with concentrated nitric acid gives us water, carbon dioxide, and then nitrogen dioxide gas. Okay, so these are redox reactions of carbon when it reacts with concentrated sulfuric acid and nitric acid. The last thing that we can perhaps think about or even do more reading about, we are not concentrating much on them, are the carbides, which are compounds that we form when we have carbon reacting with a metal or a metalloid. So we are not going to focus a lot on them, but it's something that is good for you to know. Just note that carbon can form bonds with metals or metalloids, and their behavior quite varies depending on the nature of chemical bonds that are formed. Okay, we have beryllium carbide, we have calcium carbide, and many other carbides there. So in this presentation, we have basically noted that the carbon reacts with oxygen depending on how much oxygen we have. If we have plenty, we have carbon dioxide. If we have minimum, we have carbon monoxide. We have also seen the reducing power, or we have also seen carbon as a reducing agent for oxides lower in the reactivity series. And then we have also seen the redox reaction with concentrated hydrochloric acid and also concentrated nitric acid. We will have reduction and oxidation taking place in this reaction or in these reactions. And lastly, we looked at the carbides.